Let us now go for halogen compound. I mean haloalkanes and haloarenes. Okay. Now, first of all, what are halogen compounds? These are the compounds formed by the replacement of hydrogen atoms by halogen atoms. Okay. If the hydrogen atoms of a hydrocarbon, specifically aliphatic hydrocarbon, are replaced by halogen atoms, we get haloalkanes. What are alkyl halides? These are formed by the replacement of hydrogen atoms of aliphatic hydrocarbons by halogen atoms, right? Aliphatic hydrogen atoms, so are alkyl halides. Next, coming to this haloarenes are aryl halides. No, these are formed by the replacement of hydrogen atoms of, say, aromatic hydrocarbons by halogen atoms. Okay. So this is all about what are halogen compounds in general. Haloalkanes are alkyl halides. Then haloarenes are aryl halides. Okay. Now let us see the classification of halogen compounds. Let us consider a classification based on the number of halogen atoms. Say, depending on the number of hydrogen atoms replaced by halogen atoms, these are of different types. Like if one hydrogen atom is replaced by halogen atom, we call them monohalogen compounds or monohalogen derivatives. Similarly, if two hydrogen atoms are replaced, we call them dihalogen derivatives or dihalogen compounds. 3 tri, 4 tetra, many poly. Okay, let me give you example. Look at this. In this case, one of the hydrogen atoms is replaced by a halogen atom. Okay. If you want something in general, you can take it this way. RCH2S. We can call this monohalo alkane. Okay. Because one hydrogen atom is replaced by halogen atom. Next. If two halogen atoms are replaced, two hydrogen atoms are replaced by halogen atoms, we can call it a dihalo compound. See, this can be called dihalo alkane. And if three hydrogen atoms are replaced, by halogen atoms this way, we call it a trihalo alkane. And see, even there is something like this. All the four hydrogen atoms are replaced by halogen atoms. Then we call this a tetrahalo alkane. Okay. Not just in aliphatic, a similar thing can be taken in aromatic also. Now look at this. So this of course is monohalo arene, because one of the hydrogen atoms is replaced by a halogen atom. Now this is dihalo. Of course, this dihalo, what I gave is ardo. It can even be meta or para also. In general, it can be shown this way. So this of course can be ardo, meta or para. Okay. Then even a trihalo. Okay. this way, halogen compounds can be classified on the basis of number of halogen atoms in them. Then let us take compounds containing sp3 carbon halogen bond. In fact, we have two different varieties. One in which the carbon halogen bond is of sp3 carbon halogen type. The other one in which the carbon halogen bond is of sp2 carbon halogen type. Now in this again we have three varieties. First of all, alkyl halides are haloalkyls. Okay. Here the general formula can be given as CnH2n plus 1x. Okay. Let me give you an example here. We'll give more and more examples later once the classification is done. See, in this type of compound, the halogen atom is attached to an alkyl group. I mean to the carbon atom which is of sp3 type of an alkyl group. Let me just give you an example. This. Okay. See, the hybridization of this carbon atom is sp3. Next. We have allylic type of halide. See, this is called allyl group. Okay. Now this is allyl halide, wherein the carbon halogen bond is again of sp3 type, sp3 carbon halogen bond. We can of course take this. Look at this. So this is allyl type. And this carbon is of sp3 type. Okay. Next. benzylic halides. We know that a carbon atom connected to benzene ring is called benzylic carbon. Okay. So this is again sp3 type. This part is called benzylic. Okay. So based on the type of hybridization of carbon to which the halogen atom is connected, we have two varieties. This is the first one, in which again we have three different varieties. Now let us go for the second variety, that is compounds containing sp2 carbon halogen bond. Within this we have vinylic halides and arylic halides. So this is vinyl. Halogen. This is vinyl halide, in which the hybridization of carbon atom is sp2. We can also take this. Even this is vinylic arrangement, right? Here the hybridization of this carbon is sp2. Then it's aryl halide. Halogen atom is attached to aromatic hydrocarbon. So this carbon is of sp2 type. Okay. Let us take the nomenclature in detail. Starting with, of course, the aliphatic type. Within this, let us go for the monohalogen derivative. Or, of course, alkyl halides. Mono. Now, in this case, see the general formula is CnH2n plus 1x or Rx. Functional group is this, called halo. The IUPAC name is haloalkane, and the common name is, of course, alkyl halide. Okay. Let us take different types of alkyl halides. Compound, IUPAC name, then common name. Okay. Let me take this. See, it is in fact methane, wherein a hydrogen atom is replaced by chlorine. So we can call this chloromethane. Okay. Common name is methyl chloride. Okay. Now in this, the carbon, the type of carbon atom to which halogen atom is attached is the primary carbon. What is a primary carbon? A carbon atom connected to one R and no other carbon atoms is a primary carbon. So this is a 1 degree alkyl halide. Okay. Next. We can take this, something with 2 carbon atoms. This of course is chloro derivative of ethane. So is chloroethane. Then the common name is ethyl chloride. And even this also is a 1 degree alkyl halide, a primary alkyl halide. Now, let us take something with 3 carbon atoms. Starting from 3 carbon atoms, you need to be little careful. You have to give numbers to the carbon atoms. Now this is 1 chloropropane. The common name is, say this arrangement is called normal arrangement. So the common name is N-propyl chloride. And now this also is of 1 degree type, a primary alkyl halide. Now, in this, the halogen atom, chlorine is connected to the second carbon, so we can call this 2-chloropropane. And the common name is, this arrangement is what we call iso. Iso. Of course, this CH3 can be written here also. That is the basic iso structuring. Isopropyl chloride. Now this isopropyl chloride is a secondary alkyl halide because halogen atom is attached to a secondary carbon. Now, say this is 1-chlorobutane. Common name is N-butyl chloride. Again, a primary type of alkyl halide. Look at this. See, we can call this 1-chloro 2-methyl propane, nothing but isobutyl chloride. Look at the arrangement. I told you that this is iso. 3 plus this carbon. You got a total of 4 carbons. So isobutyl, but still this is a primary alkyl halide because our chlorine is attached to a primary carbon.